Okay, this question tells us that small amounts of silver chloride dissolve endothermically according to the reaction shown. We have an enthalpy change of this reaction of a positive 65.4 kilojoules for every mole of silver chloride that dissolves. What they would like us to determine, though, is what would the energy change be, or enthalpy change be, if 0.56 grams of silver chloride precipitate out of solution. The first thing you need to notice is this is not the reaction for silver chloride precipitating out of solution. This is silver chloride dissolving. The precipitation reaction would actually be the reverse of this reaction. I'm going to go ahead and write that right now. We're going to have silver plus Ag plus in solution coming together with Cl minus in solution, and that is going to produce solid silver chloride. Now, if we reverse a reaction and write it in the opposite direction, what was once endothermic must now be exothermic. So the enthalpy change for this reaction as written is not a positive 65.4, but instead a negative 65.4 kilojoules. All right, now we're going to use that reaction to see what the energy change is for 0.56 grams of silver chloride precipitating out. We want to first change that 0.56 grams into moles. So we have 0.56 grams of our silver AgCl. We're going to go ahead, get rid of grams. I'm going to put it on the bottom here of AgCl. We're going to go to moles of that silver chloride. 1 mole of silver chloride has a molar mass of 143.3 grams. My grams are going to go ahead and go away, and what I end up with are 0.0039 moles of our AgCl. So first thing that I notice is I'm not going to get nearly 65.4 kilojoules. 65.4 kilojoules is if we produce 1 mole of this. I have very, very little number of moles, so I'm going to get a lot less energy out of this reaction. Let's go ahead and solve for this. I'm going to do the ratio method first. I know that negative 65.4 kilojoules happens to be if we produce 1 full mole of silver chloride. I want to know how many kilojoules X for the 0.0039 moles of the silver chloride. If we go ahead and cross multiply here, what we get as an answer is negative 0.26 kilojoules of energy will be released, a very small amount. Now, we could do this also using dimensional analysis if you prefer. We're going to get the exact same answer. I'm going to go ahead and start with the 0.56 grams of my silver chloride, AgCl. I'm going to get rid of grams of AgCl, go to moles of silver chloride, AgCl. 1 mole has a molar mass of 143.3 grams. Grams cancel out. Now let's change those into kilojoules. I'm going to get rid of moles of AgCl and go to kilojoules. For every 1 mole of AgCl produced, it's negative 65.4 kilojoules. My moles are gone, and at that point, we're going to get exactly the same number, negative 0.26 kilojoules. So there you have it. Watch your direction. I hope that helps.